All right, hello. My name is Aaron Gutierrez. I'm here to talk about the Mars 2020 rover. A quick little overview of what I'm going to be talking about is mainly just the goals of what this wants to achieve, considering it hasn't landed yet, the instruments, and the technology that was utilized for this mission. All right, first up is the mission overview. This is a follow up mission to the Curiosity rover. This is the Perseverance rover, launched July 30th, 2020 at Cape Canaveral Air Force Station in Florida. Hopefully, it's going to land February 18th, 2021, in the Chorizo crater of Mars. They're expecting it to last about one Mars year, which is 687 days. And basically, the main objective is just to collect samples and kind of set up future missions in Mars for actual exploration. Alright, so just a really general outline of the goals that they're seeking here is to determine if life existed on Mars, characterize the climate of Mars, characterize the geology of Mars. This is all just to prepare for human exploration. So hopefully we can use the knowledge that we gain from this mission in future missions. I will be expanding on this in the next few slides. Alright, so basically a more scientific way to look at this is we're trying to find past environments capable of supporting life, seek evidence on this type of life in habitable environments. In particular, we know that there are certain types of rocks that are actually known to preserve signs of life, so they're going to be looking at those in specific. They're going to try to collect rock core and soil samples and store them for future missions, maybe even bring them back to Earth to study them. And they're also going to test oxygen production from the atmosphere to see if it's capable for human exploration. Alright, so in order for this mission to be effective, we need to reach certain requirements first. First, we have to land on the Chorizo crater, that's important. And we want the rover to be there for at least one Mars year, which is 687 days. The most important part of this mission is to set up for that human exploration. One of the ways they plan on doing that is by searching for water resources. One of the ways we can look for the water resource is by mapping out Mars so we can know where the water reservoirs are. We have already found evidence that there might be water under the surface. Another really important thing for human exploration is that we need to map out the weather conditions because there are actually dust storms that can cover the entire planet that can be dangerous for human exploration. So they want to be able to understand how the storms develop and grow. Lastly, we want to understand the effects of geology on Mars, in particular volcanoes. We want to understand the wind, water, volcanism, tectonics, cratering, and other processes that might affect human exploration in the future. Alright, so now that we know the objectives of this mission, now let's talk about the spacecraft in particular. On the far left, we have the cruise stage, which is the part that is going to support the whole vehicle during the 7-month cruise to Mars, keeping it powered up and in communication, and on target as well. Next up, we have the back shell, which is going to work in accordance with the heat shield to form the aeroshell, which will protect the rover during the turbulent descent to Mars. Then we have the descent stage, which is actually going to be like a free-flying jetpack that we're going to use to deliver the rover, hopefully on Chorizo crater. We have the rover itself, of course, which actually has a lot of interesting technology that I'm going to delve into on the next slide, so we'll get into that later. And then finally, we have the heat shield, which is going to help slow the vehicle down during the final approach while protecting the rover from the inside from intense heat. Now I'm going to be going into the specifics of the instruments that were used on the rover. I'm going to be starting with Mastcam, and I'm just going to work clockwise from there. So the Mastcam is an advanced camera with panoramic and stereoscopic imaging capability, with the ability to zoom as well. Next up is the MEDA, which is Mars Environmental Dynamics Analyzer. That's going to be used to measure the temperature, wind speed, direction, pressure, and humidity of the dust size and shape. And we have the Mars Oxygen ISRU experiment, also called MOXIE. That's just going to be used to investigate how we can produce oxygen from Mars' atmospheric carbon dioxide. Then there's the Planetary Instrument for X-ray Lithochemistry, otherwise known as PIXL. It's an X-ray fluorescence spectrometer, and it's able to determine the elemental composition of surface materials. So that's going to be helping with our understanding of the geology. Then we have the Radar Imager for Mars Subsurface Experiment. That's just going to be a radar that can produce centimeter scale resolution of the geologic structure of the subsurface. We have Sherlock as well. That's going to be a spectrometer to provide fine scale imaging, such as ultraviolet imaging. And finally, we have the SuperCam, the last one, which is an instrument that can provide imaging, chemical composition analysis, and mineralogy. All right, I'm just going to wrap things up here. I wanted to talk about the achievements. Unfortunately, the rover itself hasn't landed yet, but as you can see, there's a lot of promising things to look forward to. We're taking the next step in setting up human exploration on Mars. The instruments themselves on the rover are way more advanced than the last one that we had. It even has upgraded wheels. The one that I'm most interested in is the SuperCam because that's actually going to be able to detect organic compounds from distances. So though we don't have any achievements yet to measure, we do have a lot of projected achievements, and looking at the instruments that we use here, I think there's a lot of potential for them. In particular, the geology one. We want to be able to characterize that for human exploration. Additionally, we also want to be looking at, some of the materials on the landing site, the habitability of the environment of Mars, if that's even possible. We want to be able to understand the weather better. And I think that's about all I wanted to talk about today. If you guys wanted to get any more information, I recommend going to NASA's website about the mission in particular. They actually have this really cool feature, a 3D model of the rover, which I know I played around with a lot. And they just have a lot of cool pictures and more information to expand on this if you're interested to learn about it more, because I know I was. Thank you all for listening, and have a good day.